given an integer array nums, return all the triplets, nums I, nums j, nums k, such that I is not equal to j, I is not equal to k, and j is not equal to k, and where nums of I, nums of j, and nums of k equal 0. So we want to return indices, or actually we want to return the elements of the array that equal 0, and the indices cannot equal each other. So for example, if we had 3 pointers here, I, j, and k, well, 0 plus 0 plus 0 equals 0, right? However, they cannot equal each other. I cannot equal j, j cannot equal k, and I cannot equal k. So the indices must be different. Okay. So if someone ran up to you on the street and said they'd give you $1 million if you could solve this, how would you solve this? Just like on a sheet of paper. Well, I think most people would solve this problem by first sorting the array. So we're given an array of nums. Here they give us this array, it's an unordered array, or at least it's not numerically sorted in an ascending fashion. But this array is. So I think the first thing that someone would do is sort the array. And then they'd take the first index, and they would say, okay, -2, what do we have over on the right side? We've got a 2. Okay, do we have a 0? Yes, we got a 0. And so they would start building out their output array, which is all of the triples that equal 0. And they'd start moving along. They'd move their leftmost pointer after they found all the triples that start with -2. They'd move their leftmost pointer to the next possible value, which is -1, and then would run the same game, right? So we'd be like, okay, -1, -1, -1, that's -2. Okay, we've got a 2 over here. And so we'd add that to the array as well. So we'd end up adding all these triples to the array. And I think most people would be able to solve this. The reason, though, that we want to be able to write an algorithm for this is because in this particular example, even though this is a medium problem here, medium difficulty, it is still pretty easy to do on a piece of paper with a pen. So we end up skipping over rules that define how to accurately solve this algorithm, as it's easier to do it using common sense than it is to do using an algorithm. But as the algorithms get harder, it is actually harder to do it with common sense and easier to do it with algorithms. So that's why it's important that we solve this problem using an algorithm. And really all that this algorithm is going to be is just a set of rules. Algorithms are only really a set of rules and edge cases. So what's the first rule that we would employ? Well, what we first want to do is we have 3 pointers. We have I'll set them down here. We have I, J, and K. So I is going to be our leftmost pointer. We'll set it here at the first index of the array. And we'll label that I. And then in J and K, we'll set in yellow. And J and K will be something that these pointers will be run on each iteration of I. So I you could think of as a for loop, and J and K will be run in each iteration of I. So we'll look at these values, right? We would tell our program, okay, start here where I is the first element, j is I plus 1, and then k is the last element in the array. And now add them up. So we have -2, that equals -4, plus 2 equals -2. That doesn't equal 0. And so in that case, what would we do? So we find that -2 is greater than, it is not greater than, it is less than 0. So because -2 is less than 0, and we have a sorted array here, we can naturally assume that if we move j to the right, we'll get a bigger number. And if we get a bigger number, maybe we'll get one that eventually matches 0. And as we can see in our case, that is what would happen. So we move it to -1. This is j. We move it to -1. It doesn't find, it ultimately ends up being -1, our triples, when -2 plus -1 is added together, that's -3, plus 2 over here at k equals -1. So we're still moving in the right direction, but because I is less than 0, or rather, because our sum is less than 0, we're going to move j again. And so this is going to be one of our rules. This is going to be one of our rules. We can call this, why don't we write this down over here? So ultimately, we're going to have 5 rules to this algorithm. And we can call it rule 4. Why not? At rule 4, while sum, we'll call all 3 elements added up, we'll call it sum. While sum is less than 0, we will increment j by 1. So increment j by 1, right? And so I'm not sure if exactly where j was. I think it was the first -1. So we continue to increment it, and this gives us the same value. We increment it again until we finally get to 0. So j equals 0. And now once we get here, we find that -2 plus 0 plus +2 equals 0. So now we have this awesome situation. This is exactly what we were looking for, where sum is equal to 0. And so we're going to add it to our array, and I'll put our array down here. So our array, we can put our array in green. It's our output array, and it's going to be an array of the triples that add up to 0. So we have -2, then we have 0, then we have +2. Okay. And when we get a triple, we're going to add it to this array. That's the first thing we'll do. And then we want to do something with j. We want to move j to the farthest possible index that has the same element. So this isn't the best example because 0, there's only 1 0. But imagine that there were, like 3 or 4 of them. Once we push this value down here, once we push this triple, we'd want to make sure that we get j to the very last instance of 0, the last instance of that element in which it was when we pushed to the array. And so that was 0, so we get it. We will get j to that final 0. So that's our rule. We can have that be rule number 2. So you might be wondering, wait, why are we doing these rules in this strange order? Well, it actually is it is the order in which we will implement it in the code. So it makes it easier to order it this way. Okay, so we have, so when we push, I'll just say when push, WP, when push, J, we want to set J to the next element, or to the last element, rather. So J equals last same element. Okay? So when we push, J equals the last same element. So J is going to equal here. And so it'll be a different index, but the same value, the last value of its group, right? And then right after that, so we'll do that, right? And right after that, we want to increment J by 1 and decrement K by 1. So now we move J to this value, and we move K to this value, right? And so why exactly did we move J? Why exactly did we move J to the last element, to the last same element? Well, the reason we did that is because imagine if there were a bunch of zeros like we just had on the screen, and we didn't move it to the last similar element or the last same element. What would have happened is when we incremented J and decremented K, we would have ended up with -2, 0, and 2, because we decremented K and there's another 2 in there. So the point is that we would have ended up with the same exact triple that we had down here. We would have ended up with another -2, 0, and 2. And we can't have duplicates, right? So that's why we have rule number 2. We can't have duplicates. We have to make sure that that J is not the same element as it was in the previous triple that we pushed. So our third rule, right? Our third rule is that we'll increment J and decrement K after pushing a triple onto our array. So directly after we push a triple onto an array, we will make sure that J is set to the last value of the type that it was pushed. And right after we do that, then we want to increment J by 1, decrement K by 1. So increment K. So we'll just say, we can just say when push, increment K, J by 1, so J plus plus, and then K minus minus, right? And we will continue on. So we've got -2 plus 1 plus 2, and that ends up being 1. So what we would do in that case is we would actually instantiate rule number 5. We would execute rule number 5. And rule number 5 is if sum is not equal to 0, but instead if sum is greater than 0, and in this particular case it is. So if sum is greater than 0, which it currently is, because -2 plus 1 plus 2 is 1. So what do we want to do? Well, we want to make our sum smaller so that it becomes closer to 0 and hopefully is 0 if we get lucky. And lucky for us, k here can be turned from 2 to 1. So we set k to 1, we decrement k, and what ends up happening is we get a value that equals 1. I'm sorry, that equals 0, right? So if sum is greater than 0, we want to do k plus 1 or k plus plus. These are the same thing. And there we go. So these are most of our rules. We also always want to make sure that j is less than k, right? We don't want to overlap where we just keep going. So like for example, in this case, we just pushed, right? So we would do step 2 and then immediately after step 3, right? And in that case, if we did step 2, we'd be moving j all the way over to here. And then we'd be moving j, like that would be step 2. And then step 3 would be moving j to here and moving k to here. And so j is no longer less than k. We would start to, if we kept going, we'd start to duplicate triples, and we don't want to do that. So we will only do this internal loop, this internal while loop, while j is less than k. So for each iteration in our outer for loop with I over here, this is the big guy. I over here is the big guy. He's the boss. And j and k are the inner for loop, or not a for loop, but they're the inner loop that will continue to run while j is less than k. And so when we get to a position where j is no longer less than k, what do we want to do? Well, that's when we finally want to iterate our for loop. And so we want to move I plus 1, right? So we would move I here. But if we moved I here, what would happen? Well, we'd then set j and k. So we would set j to be here, k to be here, always at the first iteration, right, of I. Or rather, on each iteration of I, we want to set j to equal I plus 1 and k to equal the last element in the array. So we'd have j and k here. But let's say we go through this, we actually end up getting duplicate triples. For example, this 2 right here is our I, -2 rather. And then as we move through, j would eventually become this 0, and k would remain this 2. And so we have -2, 0, and -2, and we already see that down here. So we need to be wary and avoid duplicates. And the way to do that when in relation to I is we want to look at the element before and see if it's of the same type. See if it's of the same value. So basically, once we get here, right? Once we get here with I, we'll say, okay, let me keep this in red. So once we get here with I, we'll say, okay, we're at -2. Is the value before this also -2? If it is, don't run anything in the for loop. Let's just increment again and get to the next element. And since it is, we will do that. So since we've got a -2 right here, and the value before it is a -2, we'll basically just increment I one more time until that condition is not true. And so we increment I again, we move it to here, and then we say, okay, is this element the same as this element? Rather, is this element the same as this element? And it is not. So we know we're at a new element for I and then we can begin. So we would set, let's erase some of this stuff here. We would set this first instance of -1 as I, and then we'd set j as I plus 1 and k as the last element in the array. So I would be here, then j would be right here, and k would be over here. So that's how that would work. And those are all the rules. So if we want to, basically if I is greater than 0, so if I is greater than 0 and I, or rather we could say nums of I, so nums of I is equal to nums of I minus 1. And I know this is not the best handwriting here, but basically we're saying if I is greater than 0, so if I is greater than 0 and nums of I is equal to nums of I minus 1, what we want to do is we want to just skip all the code in that for loop and iterate to the next element in the array, and finally hit a condition where, or hit a state where this condition is not true. So let's hop into the code and let's solve this in both. Let's implement this solution in both JavaScript and Python. All right, so let's solve threesome in JavaScript. Now the first thing we're going to do is create an array called ARR. Array equals an empty array. And then we'll handle our edge case. And the edge case here, when breaking up an algorithm, you can look at it in two ways. There's edge cases, and then there's rules on our logic that our algorithm should follow. So in this case, the edge case that I can think of is if nums.length, so the length of our nums array, is less than 3. So if there aren't 3, numbers in this array, then how could we have any triples at all, right? So if this is true, we will return ARR. We will return an empty array. Now let's sort our nums array. So we're getting into the actual algorithm rules part. So the first thing we want to do is we want to take our nums array, we want to sort it. And the way to sort an array in ascending order numerically in JavaScript is like this. So this will give us an ascending numerically sorted array. And then we can open a for loop. So for I, while I is, we'll let I equal 0, and while I is less than nums.length minus 2. And you might be wondering why we're doing minus 2 here. The reason is because let's say that we have 1, 1, 2, 3. This is our array. Okay, this is our nums array. We will have I, j, and k, right? We have 3 pointers. So we always need at least 2 spots, one for j and one for k. So I can only ever go to this third to last spot. And that's why we have this function running while I is less than nums of length minus 2. So it'll run when I is this position, but it won't run beyond it. It won't run when it's here or here. Anyway, let's continue moving on. So the first thing we want to do is remember our rules from earlier. Our first rule is if is when we are incrementing I, we want to make sure that it's not the same value as it was last time. We want to make sure that the I that we're incrementing to is a new value. So the way we can do that is with an if statement. So if I is greater than 0, so I needs to be greater than 0. So on the first iteration of I, we will not run this. And I, or nums of I, if it equals nums of I minus 1. If this is true, if this statement is true, we will continue on. We won't run anything in this for loop. We'll just continue on to the next iteration. Now, moving on, we can now create our k and j pointers. So let j equal I plus 1, and let k equal nums.length minus 1, right? And this will put since arrays are index of 0, this will put k at the last position in the array. Now we can open up a while loop. So while j is less than k, so we want to continue trying different triples and different numbers, different indices, as long as j is less than k, right? And we want to check, first off, let's check if nums of I plus nums of j plus nums of k equals 0. Now, if this is true, we want to do a couple things here. First, what we want to do is we want to push onto our array. We want to push this array of nums of I, nums of j, and nums of k. So we're pushing a triple onto our output array. And then we want to implement our second rule of this solution, our second rule for this algorithm to have. And this set of rules, by the way, set of rules in edge cases is really what makes up the algorithm. So our second rule of this algorithm is when we have a triple, we want j to be moved to the very last index where the value of j is the same. So we can have a while loop for that. So we still want to make sure that j is less than k. We always want to make sure j is less than k. And then we want to check nums of j. Is nums of j equal to nums of j plus 1? And if it is, let's actually increment j, right? So just for example here, let's say that this was our array. Let's say this is our array, and we have I here on our first iteration, we have j here, and we find that, let's say that this is 2 actually, or we have a 1 and a 2. We find that these two values, so I is here, j is here, and k is here, and that would equal 0. And so we would push that onto our array, and remember j is right here still. We want to move j to the last indice that has this value. So we increment it once, then we increment it again, and then we see that while j is less than k, which it currently is, k is over here, j is currently here, And nums of j is equal to nums of j plus 1. So if we look at nums of j, which is -1, versus nums of j plus 1, which is 0, we will no longer increment j. So we push it to the edge of its value, of that set of values, right? And then what we do is we implement our third rule, and that's after appending and after setting or executing rule number 2, we will both increment j and decrement k. So j plus plus, k minus minus. And that would push j to 0, and that would push k to 1. Now, let's continue on, and there's actually 2 more rules. We could think of it that way. There's 2 more rules. So we've got this if statement, and then we could have an else if statement here. Else if nums of I plus nums of j plus nums of k equal to 0, and we'll say if it's less than 0, then what would we want to do? If the sum of these values is less than 0, we would want to increment j. We'd want to make j bigger so that our value becomes bigger. And hopefully it hits 0 if we get lucky. And we can do this logic again, except this time we'll say if it's greater than 0, what do we want to do? We want to decrement k by 1. So this needs an if. Else if, and we want to decrement k by 1. And then lastly, we want to return array. Now there may be something I'm missing. However, let's run it and see. Okay, so it looks good. Let's submit it to make sure that it's all correct. Beautiful. All right, so that's how you solve it in JavaScript. So first thing we want to do is create our output array. So array equals an empty array. And then we'll check our edge case here. And the edge case is if, no parentheses in Python, if nums, or if length of nums is less than 3. So if there's less than 3 elements in the array, we want to just return, an empty array, or we can return our array because it currently is an empty array. Then what we want to do is sort our nums. So nums.sort, same function name as JavaScript. However, we don't need to return, or we don't need to pass anything into the parameters here. So we pass nothing in as arguments. It will sort nums numerically in ascending order. And it's exactly what we want. All right, so now let's create our for loop. So for I in range of length of nums and then -2. And we have the -2 here because, again, if we had a nums array of this, j and k, we have 3 pointers. So if I was here, j would take up this spot and k would take up this spot. And since our indices need to be, they need to not equal each other, they have to be separate. So this is the last position I could be, which is range length nums -2. Okay, so in here, we want to implement our first rule. Our first rule is if I is less than, if I is greater than 0, I keep doing the parentheses. If I is greater than 0 and nums of I is equal to nums of I minus 1, right? Then we want to increment, we actually just want to continue. We just want to pass through, continue. We want to pass through and move on to the next iteration of the array. And now we'll move on down here. We can create our variables. So we'll say j equals I plus 1, and then k equals length of nums minus 1, which will put k at the final position in the array, since arrays have an index of base 0. Now we create this while loop. So while j is less than k, we want to run what's in here. And so while j is less than k, we're going to actually implement our second rule. So if our sum, right? So if nums of I plus nums of j plus nums of k, if this equals 0, then what are we going to do? Well, first off, we want to append to our array. We want to append these values. So nums of I, we want to append them as an array, right? So nums of I, nums of j, and nums of k. That's what we want to do. And it's right after this that we implement our second rule, which is while j is less than k, we always want to check that, while j is less than k, and while nums of j is equal to nums of j plus 1. So we're basically checking to make sure that if nums of j equals nums of j plus 1, we are going to increment j by 1. So j plus equals 1. And so that's to say, real quickly, -2, let's say we got -1, -1, oops, -1, 1, 1, 2. If this was I, -2 was I, -1 was j, and then, I guess we would have like 3 being k. After we append our array with those values, we'd want to move j to the last indice that has the same element. So the last indice of this element, -1, which is over here. And the way we check that is to say, while j is less than k, and nums of j, more specifically, nums of j is equal to nums of j plus 1. So is that true here? Yes. -1 is equal to -1. Is it true when we're here? Yes. -1 is equal to -1. So we increment. Is it true here? -1 is equal to 1. No, it's not true. So we pop out of the while loop and we continue on. And so what we want to do now is our third rule. And our third rule is we want to increment j by 1, and we want to decrement k by 1. So we just do j plus equals 1 and k plus equals 1. Now we can pop out of this if statement and do our fourth and fifth rule. So elif is else if nums of, so we're going to take this value here, nums of I plus nums of j plus nums of k. If that is less than 0, then we want to make our sum, this is our sum. We could call it sum. We could make it a variable so we don't have to keep using it like we've used it twice already. But let's just keep moving forward as we've been doing. this we'll just call this like our sum. So this, if our sum is less than 0, we want to make our sum bigger. And the way we would do that is by incrementing j, right? So j plus equals 1. And then we'll do the same thing for k. If k is, so if our sum is greater than 0, we want to make our sum smaller. So we will do k minus equals 1. And I think that's all we need to do. So the last thing would be to return, right? To return our array. And that looks like it's it. Now, usually some error comes up when you run it. So let's run it and see what we find. Okay, expected, need a colon there. Need another colon here. I always forget about the colons in Python. Okay, list indices must be integers or slices, not tuple. Looks like I'm passing in, there's an issue here. I think that solves it. That looks good. Just had an error with the bracket there. Wrong case. Okay, so output was nothing. All right. Oh shoot, I meant to say if length of nums is less than 3, right? Because if it's less than 3, we want to return nothing. And that's why I was returning nothing here. Because we had it as greater than 3, or I had it as greater than 3, and it should be less than 3. So if length of nums is less than 3, we just want to return an empty array. Otherwise, we want to continue on with the program. So let's run this, and hopefully this will work. Of course. List index out of range. So let's look at our 5 steps here. So we've got our if statement. If I is greater than 0 and nums of I equals nums of nums of I is equal to nums of I minus 1, continue. Then we set j to I plus 1. We set k to length of nums minus 1. And while j is less than k, if nums of I plus nums of j plus nums of k equals 0, there's a list out of range here. Array for I in a range of length of nums minus 2. If I, so this all looks pretty correct to me. So maybe it is something that has to do with this right here. Here we go. So in this while loop, we're meant to increment j by 1 and decrement k by 1. So it should be k minus 1, and that's why it was actually pushing k out of bounds, out of the range of the. There was no index. There was no actual element at that index, right? So that's why we got a list index out of range error. So let's go ahead and run this, and hopefully, if we cross all our fingers, okay, there we go. And let's submit it to make sure that it is fully correct. Great, okay. So here is the full code, and that is how we solve it in Python.